Honors Algebra 2 students, here we go again. Control your excitement out there. We are going to shift around our sine and cosine waves. And this first slide has a lot of info you probably want to put in your notes. And I'm going to talk about it for just a minute. If you remember our parent function, y equals a sine bx, we are adding the h and the k. And you should remember from chapter 3 that k is the easy one. It's the vertical, k for vertical, up and down, and it's just what you would think. Plus is up, minus is down. The h is the horizontal, and it's in parentheses, and if you remember all that, plus h is to the left and minus h is to the right. We would have spent time on decimals messing around with all that kind of stuff, but I'm sure you will remember it and get used to it. And remember the reflections over the x-axis. So if we put a negative sign in front of there, we've got our reflection over the x-axis. Remember, our formulas still hold true. Amplitude is a, period is 2 pi over b, frequency is b, and here is our parent for the cosine function. Notice we've added that h and k again, and the same things apply as to a sine function. So, control your excitement. We're going to do a lot of graphing here, and we'll start off with just getting used to our new equation. So y equals a sine b x minus h plus k. Nice thing is it goes alphabetical. A is amplitude, b helps you find the period, horizontal shift, vertical shift. This problem, a is 1, b is 1. There is no h, and k is 5. So remember, h is going to show up in parentheses. So how was this graph shifted? It was shifted up 5. We move to letter b. In this problem, a is negative 1. b is still 1. H is in parentheses, so it's a plus h, and k would be outside, and there is no k. So in this problem, we've got a reflection over the x-axis. That's where that negative comes in. A is still 1, it's a negative 1. The amplitude is the absolute value of a. B is still 1, period is still 2 pi. Our h is plus pi, so we are going to go to the left pi. Remember, plus is to the left, and k is still 0. So those are our two different shifts, where letter A only has 1. Hey, guess what in letter C? How many shifts are we going to get? 1, 2, 3. Amplitude is 1. The period is 2 pi over b. H is our shift horizontally. K is our shift up and down. So in this problem, we've got a period of 2 pi over 3. That's not really a shift, but it's going to change the wave. We've got a minus pi, so that's going to be to the right pi. And we've got a minus 4, which is going to be a down 4. So I guess technically this only has 2 shifts, but I do want you to notice what all the letters stand for. A is 1, B is 3, H is minus pi, K is minus 4. Now letter D, we got to give you a little challenge. I would rewrite this one, everybody, and this will make you think a little bit. Remember, it goes y equals a sine b, x minus h in parentheses plus k. Well, if you notice, a is actually right here. So the 6 could be moved to the end, and we could rewrite this equation as negative sine 2 x minus pi over 4 plus 6. Notice the negative sign is right in front of the word sine. It is not in front of the 6, so it is a plus 6. So our plus 6 is our k. Our h is minus pi over 4. We've got a reflection with a, and we've got a period of 2 pi over 2. So the shifts would be a reflection over the x-axis. It would be to the right pi over 4, and it would be up 6. And if you wanted to write down that the period changed, you could, but that technically is not a shift. But it's nice to kind of see what all the letters stand for. So get used to this equation, everybody. Y equals A for amplitude, can be sine or cosine. B for frequency and period. And now here's the new part. X minus h plus k. All right, let's do some graphs. This will be fun, and it'll be a good review. Here's our parent function. I'm going to do that one in my black marker. If I can find my black marker. Give me 1 second. I left it over here. Okay, now we've got a black marker. Cosine starts at 0, 1. This is the parent function. The period is 2 pi, 1. Halfway in between it is down low. And then you've got your 2 x-intercepts. There's your parent function. Are you making a nice smooth graph? No lines, no slope. Remember, it's smooth and it curves. Now we're going to do letter B. This is my k. Remember, in my equation, a sine or cosine, b, x minus h is in parentheses, everybody. So this problem has a k. So I'm going to take all 5 of those points and I'm going to go up 2. So take this point, up 2, up 2, up 2. And you can see a really simple cosine wave that's been shifted. Got to start small. And for this last one, it tried to throw a curveball at you right away. It's the same as the cosine of x minus 3. Notice the negative sign right in front of the 3. So in this one, it would be down 3. So I'm going to take my parent function down 3. Again, take all the dots. 1, 2, 3. And there should be 5 of them. Again, try to make nice, smooth, pretty, beautiful waves. Hey, you just shifted a cosine wave up and down. Now, you're going to shift a sine wave. So let's remember what sine looks like. This is going to be our parent function. We'll do it in blue. Sine starts at 0, 0. Sine ends at 0, so 2 pi 0. In the middle, it is at 0 once again. And remember the slope or the curve of it, it's going to go up before it goes down. Here is 1 period of the sine wave. Now in red, I'm just going to do a shift. I hope you guys can all see that this is an H or horizontal shift. Minus is to the right, pi over 2. So now I got to look at my x-axis. Pi over 2, everybody, is 2 spaces. You can see that pi is 4 spaces. 2 spaces is a half a pi. I'm going to take all of these blue dots to the right 2 spaces. And again, I'm trying to take 5 of them over. This one doesn't quite fit. So I'm going to leave that one off. It would be out here somewhere. So there is your shifted sine wave. Again, I'm trying to keep it simple. We're just doing 1 period or cycle. You could do more than that. I think you could figure that out. Here we go again. We'll do, this is great. More practice of sine. Starts at 0, ends at 0, 0 in the middle. What goes up must come down. Boom. Let's do the other side. Starts at 0, ends at 0, 0 in the middle. What goes down must come up. Now you can see 2 cycles. Now this red graph, this is my H again, plus is to the left. I'm going to take everything to the left pi. So that's going to be 4 spaces. So I'm going to take all of the high points, left 4, 1, 2, 3, 4. This one's off, 1, 2, 3, 4. Now I'm going to take all the low points, 1, 2, 3, 4, 1, 2, 3, 4. Now I'm going to take all the points in the middle left 4, but if I go left to right, that one's off. Look where this one goes, 1, 2, 3, 4. This one, 1, 2, 3, just going right where it was. So you can probably guess, how pretty is this picture? There is your shifted sine wave. I told you it'd be fun. Cool pictures, sine and cosine. All right, let's add another element here. This one has an amplitude of 4. So it's still going to go through 0, 0. It's still going to be 2 pi 0. It's still going to be pi 0. I hope you've been practicing your sine wave. Now you're going to go up 4 in between and down 4. Here is 1 period or cycle. I'm going to do the other side just because I can do it pretty quickly. Ends at 0, 0 in the middle. This one, to make it look symmetric and pretty, it's going to go down before it goes up. So there's 2 cycles or 2 waves for sine. And now what do we do here The absolute value of -4 is still 4, so the amplitude is 4, but we have a negative sign in there. So this one is going to reflect. And for this one, we reflect it over the x-axis. That means all of these points on the x-axis are not going to move. If you flip them over the x-axis, they're going to stay the same. These high points are going to come down low. And these low points are going to go up high. This is going to be your coolest picture, everybody. So when it says flip it, we are flipping it over this line. If you're on that line, you don't change. If you're above it, you come down. So look at my new. How pretty is that picture? So you've seen some simple shifts, I would call them, and now it's time to up your game. So we're going to do a cosine graph, and you could graph it without shifts and then move it. I'm going to take you right through it and go through all the pieces here and see if you can follow me along. I think it's really nice to write down the equation right next to the problem so you can see everything. A is 3. This one is not reflected because then you would see a negative sign in front of the 3. The frequency is B, it is 1. The period is 2 pi over B. This one's nice, it's still 2 pi because B was 1. The horizontal shift is to the right, pi over 2, and the vertical shift is down, 2. So putting the letters that correspond for A, B, H, and K helps you a lot. You could graph it without shifts and then move it to the right, pi over 2, and down 2, but I'm going to show you the way that I want you to start thinking about it. I'm going to go to the right, pi over 2, and draw a new y-axis. I'm going to go down 2 and draw a new x-axis. Here is my new origin. Notice where it was shifted. Right pi over 2 and down 2. Now, if you can picture a cosine wave starting here, it will really help you out as you take a look at the graphs and work backwards. So I'm going to go from there, and I'm going to do an amplitude of 3. Cosine starts on the y-axis, up 3. The period is 2 pi, so now I'm going to go 2 pi, but I'm shifted over 2, so I'd go 2 past that. You can't quite see it, but it would be over here. All right, so my period is still 2 pi, which is 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. So halfway in between, or 4 spaces, I would go down 3. So that's dealing with the amplitude. And now, in between those are your x-intercepts. So this is how much of the graph you would see. Now, if that seems way too hard to you to start, I am going to go back and do it. I just had a change of heart. I will do it the other way. And this is a way that I was taught many years ago. That you might like it. You do it without the shifts first, and then you shift it at the end. So I'm going to do it without the shifts, but I'm going to use open dots because those are not my final answer. So without the shift, this is a cosine graph that has an amplitude of 3 and a period of 2 pi. Well, it'll start at 0, 3. It'll be at 2 pi 3. At pi, it'll be down 3. And it'll be halfway here and halfway here. Now, I said I was going to use open dots. So I'm going to do that again with my open dots. Start at 0, 3. 2 pi 3. Pi would be down 3. Halfway in between are my x-intercepts. Those are my 5 critical points. Now I can shift it. Right pi over 2, down 2. I'm going to go to blue here. Right pi over 2, down 2. Take this one, right pi over 2, down 2, it doesn't fit. You can still see I have that point left over. Take this one, right pi over 2, down 2. Right pi over 2, down 2. And here would be the same graph that I showed you before. So there's 2 ways to do it, and you can pick which way you like better. My first way will help you out as we get to some harder ones.